Hi everyone. So 2-5 pre-calculus part 3. Please pause the video, then try. Here's my work. First, you have to factor denominator. So I did the factoring. -3 times 4 makes -12. So this is the function after I factor the denominator. I did vertical asymptote first. So vertical asymptote is what? Denominator equal to 0. So I got x equal to 3. I got x equal to -4. Domain is just from the vertical asymptote. Horizontal asymptote, I compare highest power of highest power of x on numerator denominator. We got higher power on denominator. So you got y equal to 0. I didn't ask for the range, so you don't have to do range. But if I did, it would be something like that. X-intercept, I plug it in y equal to 0. Solve for x, multiply by denominator both sides. If you remember shortcut, do you remember? Numerator equal to 0 is how you find x-intercept. Numerator equal to 0. So if you remember that shortcut, you will jump into here. It's not. So we got no x-intercept. Y-intercept, we plug in x equal to 0. We got this. So that's how you get the answer. Example 3. Vertical asymptote, horizontal asymptote intercepts, then graph the function. State the domain. Okay. So you need to factor. You need to factor denominator and numerator. So I will factor numerator first. X squared minus x minus 12. So 1 times 1 makes 1. 3 times 4 makes 12. I need a minus 12. So 3 times minus 4 makes minus 12. Multiply. 1 times 3 makes a positive 3. Add them, you get -1. This number should match coefficient of x. -1, they do match. We found a combination. Then what? You need to write x here, parenthesis. First floor, second floor, write it down. X plus 3, x minus 4. I did factor the numerator. You need to factor denominator as well. So 2x squared minus 8. I see GCF 2 and 2. Factor 2 out. Then I see another formula here, x squared minus 2 squared. Because 4 is the same as 2 squared. That's a squared minus b squared form. So you can use the formula x plus 2, x minus 2. I factor the numerator denominator, so I can rewrite this equation as f of x equal to, numerator was x plus 3, x minus 4, all over 2 times x plus 2, x minus 2. Okay? Then what? I'm going to deal with the vertical asymptote first. Vertical asymptote is what? Let denominator equal to 0. 2 equal to 0, you can set that up. 2 equal to 0. Is 2 equal to 0? No. You're not going to get anything from there. X plus 2 equal to 0. So you will get x equal to minus 2 from there. X minus 2 equal to 0. You will get x equal to 2 there. So you got 2 vertical asymptotes. So I got x equal to, basically I got x equal to plus minus 2. So I can write down x equal to plus minus 2 is a vertical asymptote. Okay, we can knock off domain. X is not equal to plus minus 2 right there. Horizontal asymptote. Compare power of x, second power, they are tying. So leading coefficient over leading coefficient, so 1 over 2. So y equal to 1 over 2. Okay, And we're not asking for the range, so forget that. X-intercept. Okay, x-intercept is y equal to 0. Okay, y equal to 0. Okay, now did you get the idea? Do you remember? Eventually, when you try to get x-intercept, what do? 0 of numerator. So if you don't remember that shortcut, no problem. Just plug it in y equal to 0. So y equal to x plus 3, x minus 4, all over 2 times x plus 2, x minus 2. X-intercept, plug it in y equal to 0. So 0 equal to x plus 3, x minus 4, 2 times x plus 2, x minus 2. You have to solve for x. What do? Get rid of x on denominator. How? Multiply by whole denominator both sides. So you got 0 times 2 times x plus 2 times x minus 2 equal to, this whole fraction, x plus 3, x minus 4, all over 2 times x plus 2, x minus 2 times 2 times x plus 2 times x minus 2. Basically, you multiply by denominator left and right. Why? This whole thing is going to cancel out, numerator, denominator. And look at what happened to the left-hand side. 0 times whatever, everything becomes 0. So basically, you end up with this. And you can save some time and effort if you remember this shortcut. Whenever you try to find the x-intercept, you're finding 0 equal to numerator. Numerator, let that equal to 0. So if you remember that shortcut, whenever you try to find the x-intercept, I could have saved all this work here. You don't have to do that if you remember that shortcut. Numerator equal to 0, that's how you find the x-intercept. So what? X equal to minus 3 here, x equal to 4, that is x-intercepts. I got 2 x-intercepts. So you got what? Minus 3, 0, and I got 4, 0. Okay? Y-intercept, you plug it in x as 0. Okay? Y-intercept, you plug it in x as 0. You can plug in x equal to 0. It's easier to plug in x equal to 0 to the original. So I will say y equal to 0 squared minus 0 minus 12, 2 times 0 squared minus 8. So a whole bunch of 0, 0, 0, 0. So basically y equal to minus 12 over minus 8, which is same as 4, 3/2, which is 1.5. So we got the y-intercept, which is 0, 3/2. Okay, they want you to graph it. Again, key point here is, can you graph it without using graphing calculator? Basically, can you do by hand? So I will sketch y-axis, x-axis, and I can plot the vertical asymptotes. So we got x equal to 2, you got dot, 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 dashed line, vertical asymptote here. X equal to minus 2, vertical line, dashed line here. And horizontal asymptote is y equal to 1/2. Okay, so horizontal asymptote is like y equal to 0.5. So you got horizontal asymptote here. Plot the point you have. You got minus 3, 0, minus 3, 0, 4, 0, 1, 2, 3, 4, 0. Okay, and you got 0, 1.5. So 0, 1.5. 1.5 will be something like this. Okay, I think this is pretty good. So on the right hand side, I got this point. So either you have this or this shape. Having point on the bottom, you should know I have some graph like this. Also on very this side, you have either this or this, But having a point here tells you, okay, I'm going to have action on the bottom. Okay, now this part, middle is always a tricky part. Do you remember? When you have vertical asymptote 2 on the both sides and the horizontal asymptote, what did I say? You can have graph like that. You can have graph like that. You can have graph like this. You can have graph like that. Then you might say, how do I know which one? You don't. You just have to plot a bunch of points. Okay? So, probably I will let you use calculator, not the graphing calculator. The calculator, you can calculate things. So here you probably want to plug it in x equal to 1. I want to know what's going on here. I want to know what's, so I'll probably plug in x equal to 1. I also want to get value x equal to -1. So let me see if I can get those points using calculator. Okay, so this is basically what I'm trying to do. I want to know what's going on here, what's going on. So you need to plug it in x equal to 1. So you might say, what do you mean x equal to 1? I am plugging in x equal to 1 here. Okay, so if you plug it in x equal to 1, the calculation will be like y equal to x equal to 1. So 1 square minus 1 minus 12 all over 2 times 1 square minus 8. Okay, that's what I'm doing, and I'm using calculator for that. You got what? If I do use a calculator, I got 2. If you calculate all that, you get 2. So 1, 2. You have to do that with a -1. You might say, what do you mean? Plug it in. X equal to -1, plug it into the equation. So y equal to -1 squared minus -1 minus 12 all over 2 times -1 squared minus 8. So I'll probably let you use just calculator, not the graphing calculator. So you can just calculate things. You will get y equal to 1.67 decimal. So you got 1.67. Let's plot them and see if you can get some idea. So 1, 2 is right here. Minus 1, 1.67. I think that's pretty good. Because it's going up here, it's going up here. So without doing further points, I am very positive it would be shaped like that. So let's see if that was the case with our actual graph. Yes, that was the graph. Okay. Okay, please pause the video and try. Okay, this is work here. So I set the vertical asymptote denominator equal to 0. I got x equal to 6. They didn't ask for domain, so I didn't do domain. Horizontal asymptote y equal to 2. X-intercept here. I plug in x y equal to 0. If you remember shortcut, you could jump into right here. Y-intercept calculation here. That's end of it.